Yeah, this engine, to my knowledge, was bought. It was patented in 1893 in June the 3rd, I think it is, or May the 3rd. No, May the 12th. It was patented in May the 12th, 1893, and that would be just about 100 years since that patent came out that we're rebuilding it. Now, the model before this would be what they call an LD Sawyer, which he died, I think it was in 1892, would be the year he died, and they'd made hundreds of those, and they were a return flue boiler made for the Eastern market, a small 17 horse return flue boiler with made into a traction engine. And there was
what do you mean by a return flue?
Well, the smokestack was on the same end as where the firebox is. So the
heat
fire went through it twice, which made it more efficient for the fire and easier to fire, and plus it made more use of the heat. With these, everything went straight through like a goose. But there was no, efficiency-wise, they were very poor. This type of straight flue, like everything went out. You fired at one end, but it went straight through it and out the other end. And the efficiency, I think it was rated somewhere around 15% is all you made use of. The rest all went up the pipe, which isn't very efficient.
No.
Now, in 1895, this engine, the serial number of it is a 1083, which leaves, if they started at the 1000, this engine would be the 83rd engine they built. So it would seem to me that it would be built in probably 1893. If it was patented in 1893, it was probably built in about 1895, this particular model. Another thing was this disc wheel. Now on one that would be built in 1896 or 90 or 98 or 1900 has a spoke here for an empty pin. This would be an open spoke. Now this engine has a solid disc wheel, which means that it's older due to that solid disc wheel with no spoke for an end the pin. So the balance weight of the wheel is here, but you don't see it. When they made the spoke, they cut out a chunk here, and they left the spoke in here, and they put the pin in the spoke. That left that the balance was built in. They didn't have to thicken the wheel or leave anything any thicker much.
On this one, that wheel is thicker?
Yeah.
On the opposite side?
Yeah, it's heavier. There's a heavy weight on the inside on the opposite side. That leaves that with the spoke cut out, it makes up for the balance, for the help balance. Now the history on this engine was Charlie Russell told me before he died a few years ago, in fact, that Alec MacLeod had bought this engine, and Alec MacLeod's daughter came to see me here a while after I acquired this engine. She told me that he had bought the engine new, but back in the days of the steam engine, there was a lot of engines that got repossessed because they didn't get paid for it. And the company took them back and they rebuilt them all and refitted them all with new fittings and everything. And those engines then were resold, well, next to a new engine with the same guarantee as a new engine or whatever. So, and it would get a paint job, it would get everything just like new. But this engine somehow was unloaded over around Sand Point across the river when it come from Hamilton, because that's where they were built, in Hamilton. And they would take it off the train over there, And then Charlie Russell told me that in 1904 they unloaded it off the train over there and brought it across the river on the ferry boat to Norway Bay. And when they come to the far shore over there, before they put it on the boat, they had to take the fire out of it and load it on the boat with no fire in the firebox. And it would be steamed up to drive it on, and then there would be enough steam in it when they got to this shore to drive it off the boat, and then they fired it up and drove it home, which was to Bristol, which was only a couple of miles away. So, like, it was a pretty easy way for them to get that engine coming off the CPR line across the river. And so I'm led, the way I see it, to believe that this was a rebuilt engine in 1904, and due to the engine being patented in 1893, and its serial number 1083, and if they started their engines at 1,000, that would leave it would be the 83rd engine built, and that would leave that the engine was built about 1895. And some of these engines sat at the companies for maybe 2 or 3 years or more after they were manufactured before they would be sold. So they weren't something that sold quick like our modern equipment. There was lots of engines that sat even for as much as 10 years at the plant before they were sold. Even the particular idea was outdated when it was sold, but it was still brand new. But they were building a new model, completely different, but this other model was still at the plant, never had been sold. Then a lot of the old traction engines and steam engines that were sold back in 1900 and after, there was an awful lot of them repossessed because the firemen couldn't pay for them. And there was some of them repossessed as much as 4 and 5 times before the company or the manufacturer ever got a final payment for the whole thing. But this engine now is getting a complete overhaul, and actually if it landed here in Bristol Corners, which we're only 2.5 miles from it, it still hasn't went very far in its lifetime. It did work out the Wolseley settlement and out in the Beatty and the Wolseley settlement out in North Onslow. That's where it did a lot of its work after Alec MacLeod had sold it, or probably after Alec MacLeod died. Maybe some of his family sold it or something back there. But anyway, this engine is only a couple of miles from where it landed on to be in on the Quebec side from the day it was made. But it's getting a new boiler and all refitted, all new shafts. The intermediate gear has got a new shaft. The differential gears are new, and
Can you point out those?
yeah, these pillar blocks here, there's one here and one on the other side, they're all rebobbited and ready to put the new shaft in, and
That'd be the shaft that is driven?
Yeah, that'd be where the differential would go on this side, over here on it. And a new from the 2-cylinder, the rings and the whole bit. This is the two that's one piston there and rings. Here's the other piston here and rings, and this is the dividing plate in between the two. This plate. And
So
this is your piston rod.
That fits into the cylinder.
Into the cylinder up there. And the valve, when this one exhausts, this small cylinder, this what you call your high pressure cylinder, it exhausts and it puts the steam in to this side of the big cylinder, which is the low pressure cylinder. And the call that a tandem because you got the two pistons on the one rod. You see, you've got only one piston rod, but there's two pistons on the rod. Now most of the time, if you're talking two pistons, you're talking them being two separate rods. But these, you don't. You use the steam twice. It goes into the small one first, exhausts out of the small one into the big one, and then the next time it exhausts, it goes up the stack. And it does that every time it exhausts steam.
So this cylinder right here,
This would be the cylinder here. And then there's another cylinder. The rest of it is here. This is the one here that goes out ahead.
okay, so that
So this is your
bolts
big,
onto that
this is your big low pressure, and this one here bolts directly onto the head to get to be your high pressure cylinder on the front, to give you the compound.
So it comes into the smaller diameter
First
cylinder first.
is a hollow valve, the slide valve, and the slide valve runs over on this side, Robert. The valve would be in here. I don't have it apart now. It's in here. And this particular piece here slides the valve back and forth in there. The valve would be the full width of that. And it slides forward and back. And there's three slots in there, equally spaced. And there's three slots in the valve. And as the three slots in the valve line up with each one of these individual slots, it gives it steam or it gives it exhaust, whichever way it's going. So this slides back and forth, and when the steam comes from the boiler in through the governors and down into the steam chest, it don't go into the steam chest itself, it goes into the valve. The valve is hollow, and the valve distributes the steam first out of the valve itself into the high pressure cylinder on the front. And when it exhausts that steam out of that small cylinder back in now into the steam chest, which in turn, when the port opens, goes into the low pressure cylinder, you see. And all the steam has to go through the valve first to go into the engine proper itself, due to it being a compound. Now if it was a simple engine, the steam chest would always have steam in it, and the steam would be admitted directly from the steam chest out into the whichever end of the cylinder that was required, depending on which end it was taking admission of steam in it. But it would be going from the steam chest itself into the cylinder. But these work the other way.
What
with
is the steam chest?
This whole unit is the steam chest. The steam chest to about here. That the whole chunk here. And you see this is all hollow in here, with a big slide valve running across it. And the steam is admitted from the top here with the governor down through. And your steam pipe comes out of here and goes over and goes into the governors and down into the steam chest. And then this hole is for your smokestack to go on. And your exhaust comes out this hole. And the exhaust, you see, of the engine this is what the exhaust looks like. And it sits in here. And the exhaust out of the engine blows the...
Yeah.
You know, you see, this sits in here like that, and it would be piped up to the engine here. Well, we have it all tore apart now. That would be your exhaust, you see. And the exhaust comes up here. And that, you can change the nozzles in these exhausts too. You screw that out and put in a smaller one or a bigger one to make more draft, depending on what kind of fuel you're burning. If it's wet wood or something, you'd have to have more draft for to make it burn.
And there wouldn't be any fire on this end.
No, this is what you call the smoke box.
The fire is at the other end, and the exhaust from the fire is drawn through those tubes,
Yeah,
and all around it is water jacket.
that's right. See, all around these tubes here is all water.
Yeah.
And the water would be up to about here. And from there to the top of the boiler would be what you call the steam space. You see, this is what you call your tube sheet. And this is a hand hole or mud board or clean out, whatever you wish.
So you'd have to open that up periodically and take out the sludge.
Yeah, water should out.
Yeah.
Keep your boiler clean. That's the most important part of it, is to keep it clean, keep it dry so that it don't rust.
And then that little pin underneath there, that's where the front axle would
Go on,
connect,
yeah.
correct?
That's the pedestal for the whole of front axle. This here is your big toolbox, and this one here is a water tank. They go on the platform at the back. And relined with Babbitt. We're scraping them out there now.
And Babbitt is a soft metal, right?
Yes, it's a mixture of lead, antimony, and tin. And you heat it till it melts, and you make up a dam to hold it, and you melt it in a balloting ladle, and there's what it looks like. That's metal. That's the metal there that was poured in here to make these bearings. It's Babbitt now. Put that in there and put it in the forge and heat it, and bring it up hot enough that when you stick a pine stick in it, it'll char it. It'll burn it brown right away, you know. And that's how you test it. And then when it's ready, you pour the metal right in around using what it's going to run on as a form. And you can use clay or putty or bread dough, whatever you want for to make dams for to keep the Babbitt in bounds until you get it poured. You see, if you were pouring a bearing, what you do, you set it up the same as if it was going to run, and you leave a crack here like that, and you pour a dam all the way around here of putty, and then you pour the Babbitt in to the crack, and the Babbitt will run all around there, and it'll take the form off, and that keeps the Babbitt in place, and the face of the Babbitt goes out to form the bearing against the other working piece. And that's how that works.
Lead, tin, and antimony is the same as printer's type metal.
Very much the same.
Yeah, it looks very much the same.
It may have more antimony and tin than printers would have. Maybe. In the fact, the brittleness, I don't know how hard they'd want the type. Maybe they do want it harder, I don't know.
No, I think it's mostly lead.
Mostly lead.
Yeah.
See, the
wants to be
antimony and tin stiffens it up, makes it brittle, it makes it harder, denser, or what have you. If you don't stir babbitt when you're pouring it, you don't, your lead will go to the bottom, and it kind of separates. And if you pour it in that manner, you wind up with a lead bearing rather than a babbitt bearing, you know? So if you keep stirring it up and keep the three things mixed together, this is how I heat the babbitt here in the forge. It's just a little hand-turned rivet forge, yeah? But we put, and especially if you're all alone, because babbitt you need somebody to help you, because you have to do a lot of things pretty quick to get it poured, you know, and get it into shape. And
this is the old
that's the old
engine
boiler we took off.
boiler, right?
We quite a job even to take the engine off. We cut all the bolts all off and took all the castings off of it, and we're putting on that new boiler. So this is the gear. Now this is the old worn gear here. This one. This gear's wore out. And we're taking that gear off, and here's the new gear here. This gear, we have to finish it up yet, and we've got some more grinding and cleaning to do on it.
So that's one you've made from scratch?
This
that
has
gear?
been, yeah, we used an old gear for pattern, had it poured at the foundry, and we put it on there, and that'll be a new gear going on there. We have to mark the bolt holes that go through here for to bolt it on.
You got some fancy rubber tires on there, eh?
Yeah. This gear was made off of another gear.
It wasn't made from this gear.
No, that gear is wore out, but we made it from a better gear, one that wasn't wore out. And then we built up any place that was bad with body fill, and then took that gear over and used it for a pattern, and then we wound up with that gear maybe.
Uh-huh.
So it's quite a program. I'm waiting on to get these big wheels sandblasted, because they're almost too hard to clean. Another thing we did, Robert, is I made a machine in the shop, and these wheels have all been rebored, and they fit the new axles on the engine now.
Uh-huh. Your new axles are slightly larger than the old?
They're larger,
Uh-huh.
and these wheels have been rebored. And the machine that I made for boring them, I just rebored them and then standing them against the wall like that.
Hmm.
Boring machine goes on where this gear goes on.
Uh-huh.
And it bolts to this face in here, this machine face, in behind the gear. And there's a boring bar, 2 3/16 diameter, with a cutter in it. We put the electric drill on the end of that, and it's fed right through the bearings and right through that wheel. And it's got a feed on it, like a lathe, and it feeds the cutter right through the wheel, with the wheel just standing against the wall like that. And it rebores the hub hole to fit the new axles that we put on the engine. So the axles now are new, and so is the hole where they were.
And so that was done with just a hand-operated electric drill?
Yeah.
How long did it take?
Oh, about 5 minutes for each wheel.
Really?
Not very long.
I would have thought it would take a while to bore out that
No.
hole clear through.
We were only enlarging it by maybe an eighth of an inch, eh?
Oh yeah.
And so we just fed the cutter right through, and it only took, you know, well, within a half an hour we had each wheel, half an hour for each wheel would easily bore it, and that gives us a nice new straight finished machined hole, which the size of the wheels being 54 inches, it would take a big lathe to receive that.
Uh-huh.
And
So there's no bearing in there. It's just
grease on the cast iron running on the steel.
uh-huh.
But it has run since before the turn of the last century, and I guess it's not too bad of a bearing. If they do another 100 years now just because they took an eighth of an inch out of them, I imagine the next lad can bore some out of them.
Uh-huh.
He still won't have to put new hubs in them. All you have to do is bore them again.
Yeah.
Hung vertically with a plumb bob right in front of the center hole in the same way to form an X or a cross, like a set of crosshairs. Now in this case we use piano wire all the way. Now what we do is the line as it passes the crank pin here, it has to hit dead center ways on the crank pin, like halfway between that shoulder and the head of it here. And right in the middle of the crank pin, the wire going this way, and the one coming down from the ceiling, hung vertically, cuts right across the center of the crank pin again as well. Now when you turn the shaft, the crank pin has to be centered with the wire at the top, centered with the wire at the middle, and at both sides and at the bottom. That leaves that shaft, when you put a level on it, will be perfectly level, because the boiler, before all this happened, we leveled the boiler dead level every way. That leaves then that shaft, if you put a level on it, the shaft will be dead level, and that gives us the right place to position that far steady bearing on the other side of this engine that isn't on there right now. The holes are bored and everything's ready, and as soon as that eccentric is ready, we'll put the eccentric on the shaft, then we'll slide in that bearing and we'll bolt it down. All the bolts will be put into the boiler. They thread in. They're a 7/8 bolt spine thread, and they hold that other bracket on. That leaves that your shaft is now a complete 90 every way to the engine, so that if it wasn't a straight 90 every way, the engine wouldn't run right, and on top of that you would break the connecting rod or wear out the connecting rod brasses, because the connecting rod would be now running in a, you know, as it's running, it would be going in a half circle sort of thing.